12D. Example 19. Okay, we've got 3 more examples and you guys are done with 12D. So 3 more examples and then we've covered most of the techniques that you need, algebra techniques, alright, that you need. We've gone through I think the hardest questions already. These ones are just more algebra. But the hardest technique was the one I showed you guys earlier where you need to make the pattern, alright, and then make 2 equations, then submit to the first one, yada yada. So that was the hardest technique, I think. The rest of it is just algebra. Example 19. Now this one's a bit easier, right? This one you get the equation. The figure shows a circular lake, center O of radius 2. A man swims across the lake from A to C at 3 kilometers per hour and then walks around the edge from C to B at 4 kilometers per hour. If the angle BAC is theta, alright, that's our first variable, and the total time is T, show that big T equals to this thing. Oh, it's a show that question. What do you do when you see a show that question?
Skip it.
Skip it. Okay. We'll skip that for now. Question B. Find the value of theta for which dt over d theta equals to 0 and determine whether this is a maximum or minimum value of t. Given that the angle is between 0 and 90. So I'll go through that. One then. T equals to 1/3 for. Now there's one thing that I want to mention when you're doing these kinds of equations. dt over d theta, right, is equals to what's the main idea when you see an equation like that? How do we derive an equation like this? What's the main concept?
Question.
No.
Not question. Sorry. What's it called? I'm not sure what it's called.
Well, describe it.
The chain rule, is it?
No. It is called ignoring the constant factor. Remember, if you have a constant factor times the function, the derivative will be the constant factor times the derivative of the function. You can safely ignore the constant factor, right? And then you just derive whatever is inside the brackets. Okay? So you just put the constant factor in first, and then you derive what's in the bracket. You don't actually need to times it in. The answer is going to be the same regardless. Alright, so you derive the bracket. 4 cos theta is minus 4 sine theta. And then 3 theta is just 3. Yeah? So far so good? Okay? Now, you can choose whether you want to times it or not. I will not times it in. Why? Because ultimately, we're going to set dt over d theta equals to 0, and the constant factor will just get cancelled off. Okay? So set that equals to 0, and you cancel off the constant factor, so it'll just be minus 4 sine theta plus 3. Right. Does anyone have any question about why I can cancel the constant factor? Emily, any question? I sense the question coming. If you have 0 equals to 4x, then you divide both sides by 4, right? Doesn't matter what the factor is, then you just get that. Right? Because 0 divided by any number is just 0. So that's why it doesn't matter what the constant factor is, you can just divide both sides by that constant factor, it's gone. Alright? So in this case, the constant factor is 1 over 3. So yeah, and then you solve it, move the 3 over. Minus 3 equals minus 4 sine theta, and then 3 over 4 equals to sine theta. Okay? And we know that theta is between 0 and 90, so then theta would be inverse sine of 3 over 4. So that will be, I think I'll use my calculator. It's in degrees. So make sure your thing is in degrees, inverse sine of 3 over 4. So that would be 48.5904 degrees to 4 decimal places. Okay, alright. Determine whether this gives a maximum or minimum value of t. How do we do that?
The second derivative.
Second derivative. d squared t over d theta squared. Okay, just remember the top one, the squared is between d and the main variable, and the bottom is after. Okay, yeah, so you derive it. Same thing, you ignore the constant factor, you write 1/3 brackets in here, and then you derive whatever is in it. Sine is cos, so that'll be minus 4 cos theta, and then the constant is just becomes 0, so it'll just be that. Okay, so that's be 1/3 times negative 4 cos theta, which is negative 4 over 3 cos theta. Okay, at theta equals to 48.5904, then the second derivative right, would be equals to negative 4 over 3 cos of that angle. Do you think it's positive or negative and why? Anyone? How is it relative to 0? Positive or negative? No calculator required. You can guess what it is.
Negative. I'd say negative.
Negative? Okay. Why?
Like on the unit circle, the angle would be on the right.
Mm-hmm.
On the positive side of the cos axis.
Okay.
So positive times negative.
Yes, very good. That is the perfect explanation. On the unit circle, right, this is cos axis, 48 degrees is here, right? This is about 48.59, okay? And this means that the cos value is positive. So this component is a positive number. Yeah? We can tell how? Yeah? That component is positive. And when you multiply that by a negative number, the final answer will be less than 0. Yeah? Does it make sense? When you times the negative with a positive, the answer is 0. Right? That's why, therefore, less than 0 means it's concave down, right? Therefore, maximum t. Okay, make sense? Yeah. And so the actual value t at the angle 48.5904 degrees would be substituting that into the t equation, and then you get the actual time, total time. Okay, so that would be, I think something would be 1.5. Okay, let's see, 1.73. Yeah, 1.73 hours. Okay. Any question? No? Emily, you sure no questions? Any question, Emily?
I don't really get the second last part of it. So like
Which part of it?
equation less than 0.
Like why this thing is less than 0, right? Okay. So look at this number here. So the number we're looking at is this one, and then times by cos of, we simplify it, 49 degrees. Right? Yeah? So we know this is a negative number. Times by, now we just need to know whether it's positive or negative here. Right? 49 degrees on the unit circle is about here, right? This is representing 49 degrees. Yeah? And cos of 49 is the value on the cos axis. Right? And this is positive. It will be positive something. If it's like, let's say the angle here, this will be a negative cos value. Yeah, remember the unit circle, and remember how like in the unit circle, the symmetry points, the 4 symmetry points, these 2 points would have negative cos, right? That would be negative cos and negative cos.
Okay.
Yeah, so that's why cos 49 will be then positive. So negative times positive equals negative, and that will be less than 0. Okay? All right. Now then we go back and try to do this weird show that question thing, because if you're unlucky, you may not be able to get a nice equation from the beginning. You might just get like find the equation and then you derive it. So let's try to do the show that one here. Okay, show that t equals to that. Okay, so the total time taken will be equal to that. Now the time taken, note that he swims across from A to C, so it will be this section there. All right, and then walks around the edge of the lake. Well, around the edge means it's this arc here. It's not the straight line CB. Okay, it's the arc BC. Make sense? Yeah. AC, how do we find AC? Well, we know the radius is 2, so there'll be 2 here, 2 there. All right. How do we find AC? So we need to find AC, right? So the total time would be AC times 3, right? Because it's 3 kilometers per hour times by the distance. Actually, no. The time would be, there would be AC divided by the speed, which is 3 kilometers per hour. Plus by the arc BC, right? Arc BC divided by the speed of walking, which is 4. Okay? Alright, make sense? Make sense so far?
No.
No? Okay. The time taken is time swimming. The time it takes to swim AC from A to C, right? Plus the time it takes to times walking the arc BC. Remember, the arc BC is like this one, yeah. This is from C to B here, yeah. It's the arc, not the straight line. Right, make sense? Because you're walking around that arc here. So time is equals to what? So time is distance over speed. Are you guys aware of that formula? Yeah. So how? Yeah, Emily. Yeah. So time is distance over speed, and distance is, well, for time swimming AC is AC, and the speed of swimming is 3 kilometers per hour. And then the time walking is the length of arc BC over the walking speed, which is 4. Yeah, so far so good? Okay. How do we find the length AC? Now we need to find AC, because remember we want t in terms of theta, right? Because the function is theta. How do we find t in terms of theta? Well, we need to get AC in terms of theta. How? We did this earlier.
Cos theta.
Yes. Wait, cos theta. Yeah, for cos theta. So remember, you use SOHCAHTOA. Cos theta is adjacent, which is AC over 4. Right? It makes sense now?
Yeah. Yeah.
And now when you're looking at me, you're not thinking. Okay? You have a habit of like looking at the one who's explaining. I feel like that's what we come from school. You stare at the teacher, and the teacher, oh yeah, very attentive. But your mind is drifting off somewhere. Right? So how you gotta pay attention.
No,
Right?
I understand, yes.
Okay? Right? So AC is 4 cos theta. Okay? So then, okay, let's update the function that we've got. That will be 4 cos theta over 3. And now, how do we find the arc BC? Now, this one is a bit harder. How do I find the arc BC? Not the length BC, but the arc BC. This is grade 9 geometry, but the harder part of grade 9 geometry. Okay? Alright, have a look. To find the arc BC, alright, you need to know one thing. The angle at the center, right, is going to be twice the angle on the outside. Does it make sense? Okay. Put it this way. The arc BC, right? Whatever that angle is, okay? Right? Whatever that angle is, it's going to, so the arc BC would be, let's say that's angle alpha. That would be alpha over 360 times the circumference. Does it make sense?
Oh, yeah.
Yeah? It's a portion of the circumference. The circumference is the whole thing, right? It's a portion. Well, what is the portion? The portion is this part here. And it's defined by the angle, right? So it's the angle over 360, which is the total, I think it's in degrees, right? Or radians, sorry. Radians, so alpha over 2 pi. Alpha over 2 pi times by the circumference. And what is circumference? It's 2 pi r. Right? Is the circumference. And so you can actually see that using radians is quite convenient. The 2 pi cancels out. So the arc BC, right? The arc BC would be alpha, which whatever the angle is, times by the radius, which is 2. So that's just 2 times the angle alpha. How do we figure out the angle? It's going to be 2 times the angle. How do we figure out the angle? Any idea? Grade 9 geometry. Right. Let's say if you don't know any theory, do you recognize that AOC is a isosceles triangle and this is theta? Yeah? right? Okay, which means this one would be 90 minus theta, right? Yeah, and it's also the same as this one, right? Because it's an isosceles triangle again. Yeah, so this one is also 90 minus theta. These are the same. Make sense? Right, I'll label them a bit differently like that. Okay, so what's alpha? Alpha would be
180 minus 2 times 90 minus theta.
yes, that's right. Well, in this case, we use pi. Alright, so pi minus theta. So that will be 180, which is 2 pi minus 2 times.
Is it wouldn't it be pi on 2 minus theta?
Oh, sorry, pi on 2. Yeah, you're right. It's pi on 2, 90 degrees. Yeah, does it make sense? Yeah, so you have to use a bit of geometry to work it out. That's fine. So 2 pi minus that. So expand the bracket. Minus 2 times it would be pi and then minus 2 theta. Okay? 2 pi minus pi is pi. Oh, sorry, 180 would be 1 pi, my bad. So pi minus pi is 0. So that should be, minus 2 times that is plus 2 theta. So it'll be 2 theta. Pi. Make sense? Yeah? Emily, a bit confused?
Yeah.
Yeah? When you multiply, so it will be 180, which is pi, right? That's the first mistake I made. Fix that one up. And then the negative 2 has to times into each of these ones. So negative 2 times the first would be minus pi. And negative 2 times negative theta is plus 2 theta. Right? So you use pi minus pi is 2 theta. So the angle alpha is 2 theta. Therefore, the arc BC is going to be alpha times 2, the angle times 2 in radians. So that will be 2 theta times 2 over 4.
Wouldn't the angle be 60?
No, not 60. We don't know what theta is. It could be 20, so that changes everything.
Wouldn't it be using that? Wouldn't it be 30 theta?
No, wouldn't be.
As in the one that connects to 90 degrees.
No, because you don't know what theta is. Right? You don't know what theta is. So whatever theta is, then this angle will be pi over 2 minus that theta. But theta, we don't know what theta is. Could be 30, could be 45, could be 20, could be 15. So we actually don't know. So yes, at this point, let's see what you can do here. So 2, so that would be 4 over 3, right? Cos of theta plus, and then 2 times 2 is 4, so that would just be 1 theta. And now, look at the equation here. It's just 1 over 3 times into the whole thing. So you take out 1 over 3 as a common factor, 1 over 3, and it will leave the first one with cos theta. But what do we take out 1 over 3? How do we take out 1 over 3? Well, if you times it by 1 over 3 and times it by 3, it will be the same, right? Right, so how? Yeah, it will be the same here, right? And that's why if you take out 1 over 3, you get plus 3 theta. Does it make sense? Yeah, so that's how you show that t equals to that. So you see, if you get this question in the exam, I do not expect you guys to be able to figure out the show that question. It's very difficult. Okay, it will take more time than what the mark is worth. So that's why most of the time, show that question, you normally just skip it, do the other questions instead. If you're lucky, you get a show that you can do. If you're not lucky, you can't do it. That's just normal. Okay, it's normal to struggle with the show that question. The teachers will spend a lot of time thinking about how to make a good show that question. And a lot of time thinking means the question will be very difficult. Okay, so yeah, so that's for show that questions. All right, let's see. We probably won't be able to do 2 equations at the same time, but I'll just show you the answer for example 20. It's not too difficult. The number of bacteria present in the culture is NT, and NT equals to this equation here. At what time will population be maximum? Find the maximum population. Well, it's just derive it, right? And then solve it. So when you're trying to solve this one equals to 0, so let's just say this one equals to 0, right? Let's say we don't know what t is first. How do we solve this equation here? Any idea? All right, how do we solve this equation equals to 0?
Would you split it up so it's e to the power minus 0.1t is equal to 0?
Mm-hmm.
And then
very good.
36 minus 3.6t.
Very good. Okay, and then?
And then you can do log 0 is equal to negative 0.1t.
ln 0 equals to?
Ln 0.
Right.
Equal to, yeah.
Okay.
then divide both sides by -1.
And that is where you are wrong.
Wait, there's no solution for that one.
No solution. Why?
Because
It becomes.
you can't equal 0.
You can't take log of 0.
Oh yeah, you can't. Yeah.
Yeah? You can't take log of 0. That's why no solution. And on the other side, when you solve it, you get t equals 10. Right? Pretty simple. Right? So 36 minus 36 equals to 0. So you get like 3.6 t equals 36. And then t would be 36 divided by 3.6, which is 10. Okay? And then you subtend it, you get the maximum population done. Okay? So that question, not too hard. Example 21. Maximum rates of increase and decrease. Okay. Okay, put it this way. This question is about reading the graph. All right. So let's just say for question A, right? This is a calculator question. Let's say we were to sketch that. You get this. Focus on this one here. Okay. Focus on this side here. Actually, maybe I have to snip this into the notes. All right. Now this question. Assume that the number of bacteria present in the culture, yada yada. I think it's very similar to the other question. Sketch a graph of nt against t and n dash t. Question B. So ignore question A. Question B. Find the maximum rate of increase and decrease, and the times at which these occur. So look at these two graphs. How would you do it? Let's say you already put the equation into the calculator to get the graphs. Right? How would you do it? Maximum rates of increase and decrease. Which graph do you use? Left or right?
Left.
Incorrect. The answer is right.
Oh wait.
Yeah, because it's just increasing.
Because it's the derivative. Maximum rates of increase. What does that mean? Maximum rate of increase. Right, so I actually don't use this one. So using the graph on the right, how do we find the maximum rates of increase, for example? You gotta deconstruct this. Max. Right, and then rate of increase. Rate of increase is d positive. Okay, this another way to interpret this is positive. What is the maximum positive value of n dash? Does that make sense? Maximum rate of increase is the maximum positive value of n dash. Does that make sense? Because n prime is the rate, right? Increase means positive. Okay, so rate means n prime or n dash, and then increase means you're looking at the positive values. So what are you looking at? You're looking at this section only, right? Right, because this is a graph of the rate already, right? Whatever the value on the y-axis is the rate at that point in time. It's the rate, it's not the number of bacteria, it's the rate of the change of the bacteria. Right? It's rate of change. Remember, derivative is rate of change. This is the graph of the rate of change with respect to time. So the maximum rate of increase is actually just the highest positive value of n dash, which is 36. So this is the max rate of increase. Okay, and that would be 36 unit is was it 36 bacteria per unit time, right? Bacteria per unit time. Now, does it make sense? Yeah, maximum rate of increase is the highest positive value of n dash. Any question? Emily? So how? What is the maximum rate of decrease then? How do we?
Wouldn't it just be the The lowest point.
Yes, that's right. Okay. The rate of decrease means what? Rate of decrease is corresponding to this section, right? When the rate is negative. Okay? Because when the rate is negative, the culture is decreasing. So now you actually look at this one here. You see how around 10 it starts decreasing. See at 10 it starts decreasing? Yeah? So the highlighted section on the right hand side here corresponds to the part where it's decreasing. Right? So the rate negative means the culture is decreasing in population. Right? The maximum rate of decrease is when it's at the lowest. Right? When it's at the lowest point here. Right? Roughly around here. So this one would be the maximum rate of decrease. It's this one here. Does that make sense? Yeah. So this is very important. When you have a calculator, and I think we'll do more questions next week. But when you have a calculator, when you sketch a bunch of graphs, you need to know which graph to use and how to interpret the graphs, especially the first and second derivative graphs. Well, the first derivative graph is the most important. Okay, the first derivative graph, that's the hardest one. You already understand the main one. It's the derivative graph that you need to pay attention to now. Okay, any last question? No? Remember, 2 more lessons and then it's exam time. What should you guys aim at doing now? Remember?
Any questions? Wait,
Yeah, do more questions, of course. What types of questions?
hard ones.
Yes, do the harder ones. Okay, do the harder ones to try to learn more. And then when do you start doing like revising all the easy questions?
Last 1 week.
Your last week before the exam. Very good. Okay. Go back. Please start your revision. High hopes in you guys. Make sure you do your revision to achieve the highest mark possible.
Yep.
Yep. Alright. Otherwise, somehow your mom will have both your head and mine if you mess up this exam. Okay. And Emily should manage you guys should be fine. Make sure you do your work. Okay. Just this guy.
So much stuff to do.
Let's see.
General is gonna.
Honestly, it doesn't seem that hard. Don't know.
There's a lot of shit to do.
The same, isn't it? The same amount, like 5, 6 chapters?
7 to 12, I think.